Aloha, Richard Halverson here. This is ITS148, and today is March 9th, and today we're gonna just do the labs. There's two labs at the end of chapter 15. One is adapting a selection sort, and the second one is a quick sort. And I'm going to try just to do those two labs in this class today, and then there'll be another class period later this week, and we'll start functions at then. So let me share my screen. I'm still logging into Lima here. All right, this is ITS 148, and we are this is we're here. Okay. Oh, wait, where did I say functions? No, sorry, wrong class. The next week, or what we're supposed to be starting this week, is lists, stacks, and queues, which are special cases of they are lists with that have added methods to them to make them operate in special ways, and we'll see that. All right, so class 9. So this is class number 10, and let's go to the book. And let's see, we are going to first try to do quick sort. They're descending, no, I'm sorry, second time, descending selection sort with output during execution. Now both of these labs are just basically starting with the code in the section that describes that particular sort, and then just make modifications to it. And and that's life of a computer scientist these days. It's not so much writing. Well, in fact, it is. It's this is 148. In 228, we will start getting into a bunch of algorithms. Here we talk about these selection sort, insertion sort, to different sorts, and we're also talking about these different data structures. And we're going to get into trees, and then after that, it's algorithms all about lists, and algorithms all about trees. And then after you learn all those algorithms, all the problems in computer science are basically built up from those basic algorithms. And every now and then, every few years, some computer scientist at some university will come up with some new algorithm, some adaptation of some algorithm, and it'll be a little O of n, slightly a fraction less, but and it'll make the computer science news and so on. Anyway, so in this lab, we're supposed to write 1510, write a function selection sort descend trace that takes an integer list and sorts the list into descending order. Okay, so it takes a list and sorts it into descending order instead of ascending order. The function should use nested loops and output the list after each iteration of the outer loop. Okay, so we're gonna, oh, got it. Okay, so it's gonna look like this. I'm gonna read in this list, and then the first time it's gonna print out this list, and then the next time this list, and next time this list, and you can see as it goes down, it gets sorted, and we're sorting in descending order, which means the biggest one is first, then the next biggest one, and so on. So the selection sort algorithm would start to find the right one for this one, and it would go down the whole list and find the biggest one and put that one there. It would trade, and that's why we end up with this. See, the 10 and the 30 are the same, and then so that's sorted, and this is the unsorted list. So then it's going to go here and find the biggest one, and it's going to be 30. So then it's going to exchange with 30, and that's why the 10 ends up here. And then, so this is a sorted list. This is not, we're descending sorted. And so, so the last iteration, it ends up like this. And there are n-1 iterations, as you can see. So I'm going to go to, I'm going to build this. I guess it doesn't really matter where I build it. I guess I can build it here. So I'm going to go find, no, I don't want to build it here because I'm going to be clicking around. Actually, I only have to click around once. Let me go to selection sort. And I'm going to grab this. I'm going to grab this whole thing, copy, and I'm going to go over to here. And I'm going to open up an editor here. And let me clear this. See, let me find, do I have a 148 on here? Yes, I do. And I want to, what am I doing with this? Am I opening or save? Okay, so let me get rid of this. And I'm going to paste the selection sort that I just copied from section 15.6. I pasted that in here. How you doing? And so now I'm going to convert this selection sort into this selection sort descend trace. Okay, so I'm gonna, first of all, I'm gonna move this over here. And I've copied this one, and now I'm gonna turn this into I'm gonna turn this thing, which is just the selection sort I just copied, into this. Okay, so so I'm gonna, first of all, I'm gonna change the name. And if I change the name there, I better change the name there, although I don't think it's gonna. And then for the range, it's selection sort, and but we're gonna find the largest index instead of the smallest index. So I'm gonna change this to largest, and basically we're gonna okay, so we are finding the largest. This loop finds the largest index. Yes. The largest index in a pass. Okay. So we're gonna do range. We're still gonna do the range from the top down, and that if the numbers, if it's greater, we're doing largest. So it's greater than the largest index. I'm going to change all these. Okay. So so as it goes up, okay, so it's storing an index. Okay, so in this case, it starts out storing index 0, and then it's going to go no, is index 0 small, is index 1 larger than index 0? No, it's not. Is index 2 larger than index 0? Yes, it is. So now the largest index is 2, and then it's going to see if index of 2, if index of 3 is greater than index of 2. It is. So now the largest index is 3, and so then it does the exchange. So we're trying to store the largest index, not the largest value, basically is what I'm trying to say. All right, so as we go down the list, and this definitely goes down. Does this go down the list? This. Yeah, okay. It doesn't have to go down the list. It can go up the list. I gotta get my thinking right. Yeah, it is going up the list. Yeah, it goes up the list. And each time it tests if the index, if it tests if the number at that index is if the number at that index is larger than the one that we think is the largest, and if it is, it stores the new largest value. Okay, so when this is done, okay, and then down here we have a largest index, and we're going to swap it with I, with the index of I. So, you know, the first time we're going to swap it in this position. The next time we're going to swap this position. Third time we're going to swap this position. All right, so I'm convinced that sorts in descending order, and in fact, I'm just going to run this program right here and confirm that this runs in descending order. Okay. Let me go over here, and I'm going to go CD window on desktop, because I have this on my desktop. Right. Where's my ITS148 folder? Here it is. There it is. Oops. Yeah. Okay. I'm in here. And so I'm going to go to CD ITS148, and then I'm going to do py test.py, and it goes. Yes, that is sorted in descending order. Now, I'm not nearly done yet, because this is supposed to print this out. Each time it's supposed to print out this iteration. And also they want us to do this name equals that thing. So, input. Okay, reads in a list of integers. Okay, great. So if the input is going to do something like user input equals input, that's the input, and then I got to convert it into a list of digits. Numbers equals user input dot split on a blank. Oh yeah, we want to make integers out of this, and we'll do it next. For num in numbers, I'm going to change this to nums. We aren't quite there yet, are we? And I'm going to use the append for numbers. I'm appending it onto numbers. Now, there's other ways you can do this, obviously. And here I will numberify it, integerize it. Okay. So now I've got this list of numbers here. It's a list, and it's a list of numbers that was input by the user. And so then, okay, so it looks like the printing has got to be done up here. So I'm just gonna, it's numbers, so I'm gonna copy this now. No, I'm going to do it over here. And you copy it into there. Okay, I'm going to copy this and put it, I'm not done with this yet, am I? I got to sort. Selection, sort, descend, trace, numbers. There, that'll do it. And I'm going to put, okay, now, where would I print? I would print after each iteration of I. So after the swap, I think I would just print right here, I think. I have to print the whole dang list, don't I? For J in I guess for J in numbers and in numbers, I guess. For n in numbers. Print n, comma, and then I don't want to, because I got to put it on a line. And then after this is all done, I can print the buffer. Okay, so I'm going to copy this. Oops. Copy. And I'm going to paste it right here. Oh, wait a minute. First, I'm going to run this to see what it looks like. It should print. Yeah, look. That's exactly what it should look like. Oh, except for I don't need this sorted in the. Okay, so right. I don't need this top part. Okay, so that looks like that works. So I can just take this. Well, in fact, I'm going to stop here. Okay, so what you got to do is really, this looks like it'll work. And so you would just need to copy this into right there. So anyway, you can do that. Boy, that was easy. All right, let's look at the next one. I will leave. Okay, it's gone. All right, and then here I'm just going to go, boom, gone. All right, what's the next one? Sorting user IDs. Given code that reads in some user IDs until the sentinel of -1, complete the quicksort and partition functions to sort the IDs into ascending order using the quicksort algorithm. Increment the global variable num calls in quicksort to keep track of how many times quicksort is called. The given code outputs the num calls followed by the sorted IDs. All right, so if the input's this and the output is going to be 7 because quicksort, I guess, yeah, there's no randomness in quicksort. Because that's how many times quicksort was called. All right, and this is the what we're supposed to mess with this. All right. All right, so I'm gonna take this. I'm gonna take this. Can I make this bigger? Oh yeah, good. I'm gonna take this whole thing. Copy. and I'm going to put it here. Okay, this is what I have to fix, and I have to put some, looks like I have to put something here and here. And my secret notes over here. Yes, that is true. Okay, so how am I going to do this? Well, I'm going to go over and I'm going to grab quicksort. Okay, quicksort. 15. Quicksort. Here we go. All right, so that looks nice. That doesn't look like enough though. There's not enough there. Ooh, quicksort algorithm. Here we go. We have a partition and a quicksort and some numbers. Okay, I'm going to copy this. Copy. Copy. And I'm going to go over here, and this is I'm going to turn this into that. Eventually. So I'm going to go, okay, first I'm going to create a new, and I'm going to paste this here, and I'm going to do save as test2.py. Okay. So now I have a test2. I don't need this, and I don't need this. So now I have a test.py, which is what's eventually going to be the answer to this problem here. And it looks like the only thing I really have to change is this down here. All right, so so I'm gonna okay, what's the difference between this? Here we're reading it in. Okay, all right, one step at a time. I'm just first going to get this to run and make sure I can run this. And it's got a bunch of numbers here, and so I've saved it called test2, but test2.py. So I'm going to go py test2.py. All right, very good. It's sorted. What next? I'm going to count how many times quicksort sorts. Okay, I want to do that part because I'm supposed to print out how many times quicksort was called. How many times quicksort was called? That's this one. Where does that come from? It calls it global. I'm going to do it this way. I'm going to do it a little different. Okay, so the way these sorting algorithms are working, I'm noticing, is that it passes in a list, and then it messes with the list, and then it just returns, and you know, the list is magically transformed into a sorted list. So you know, you aren't explicitly returning the list, and the reason you can do that with a list is because a list is mutable. As you know, you can change a list, whereas if you just, whereas when you're just passing, you know, value, when you're passing a variable, you're passing something where that variable is, the value of that variable, that variable with that value is recreated in the method, in the function, and so it doesn't change it on the outside. Whereas with the list, if you change it on the inside, it's changed on the outside. I hope that made sense. So anyway, I'm going to return the number of times this bugger is. All right, that's not going to work, is it? No, forget it. I'm going to create a global variable here called global number numcalls, and I got to set it equal to 0. I think I just need to do that, but somewhere I got to set it equal to 0. Oh, I do it. I guess I do that up at the. I guess I got to do it like this. It's got to see it. All right. And so every time it comes in here, it's going to increment numcalls. And when we're all done, it's going to, when we're all done quick sorting, it's going to print numcalls. Okay, so let's see this working. $15 numcalls. Okay, now I'm going to test to see if what it does with that work. Might work. I want to see what it does with this list. I'm going to say I'm going to try to do this. Numbers, it's not going to be numbers, but all right, so now I have a different list of numbers. And I'm going to see, now will this work? Because I think it might work. I think it might work. Let's see if it works. Hey, it worked. Worked, didn't it? Okay, all right, we are well on our way. What is it supposed to look like? It's supposed to look like that. Okay. Yeah, well, that's easy. I'm just gonna go this. And, oh, by the way, I don't even need this either. Do I? Yeah. Oh, I don't need the word sorted either, do I? I don't need this. Okay, that looks just like the output should look. Excuse me, I gotta check something. All right, so now I just need to, I can get rid of that too. So I can get rid of this. And I can get rid of, well, I'll tell you what, let me just, okay, well, anyway, I don't see why I can't just, that's all there. It's user IDs. User IDs, what does this look like? I'm sorry, I didn't mean to do that. What does this look like? My test 2. It's not user IDs, it's numbers, isn't it? Can I? It's not. Okay. Um, okay, this comes in, it's 3, it looks like that. And this one looks like that. Partition quicksort, user IDs IK, user IDs IK, numbers IK, numbers IK. Well, I'm gonna okay, so all you have to do is take all this code down to here. I'll tell you what, let's do it this way. Take this. Num calls equals 0. Take this. Oh, tell you what, here's what you do. Do global replace numbers with user IDS. Replace all. I'll just do one at a time. Okay. Replace, 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 replace. Replace, 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 replace. Okay, this is okay, great. So I replaced everything with user ID. Let me get rid of this. And so I would just where's the quicksort one? Oh, here's the partition one. I would just take this, copy, and paste it in here. Okay, that's what I'd do. And then I would go start here. And I would copy this, copy, and I would paste that right here. All right. Okay, I think I'll stop here, and you should be able to get this to work. You saw what I did, and I hope this helps. So it's early; it's only 11:06. Let me just let's just take a look at what Chapter 16 looks like, and we're going to be learning about all kinds of the list abstract data type. And here we're gonna start with singly linked lists, and they have some nice pictures here. Yeah, singly linked lists. And so this is what the structure looks like when you traverse through it this way. It's easy to insert a new element into the list because you can just break the path and stick one in the middle and link it back up again. But if you want to search the list, it always has to be sequential search. So that's a list abstract data type. And then we've got, we learn how to remove from the list and insert into the list, and how to search the list, and how to implement it in Python, and then W-link lists. There you have a forward and a backward link, and that's useful in a bunch more ways. And then we're going to do these traversals and how to sort them and so on. And then we're going to see how stacks are implemented and how queues are implemented. So anyway, I will leave it here. And my goal today was to finish the 2 labs in chapter 15, and I think I got you well on your way. So I will see you. There's going to be another class Thursday at 3:30, I believe, and so we'll get more heavily into chapter 16 at that time. Thanks for watching.